Welcome to On the Chain.
Matt, welcome to On the Chain once again.
Matt,
hey guys. Hi Jeff. Hi Chip. How you doing?
Doing good.
Cool.
Great. It's awesome to see you. Awesome to have you on.
Thank you. Yeah. Thanks for having me back on. It's cool.
Well, we want to learn more about Bittensor, and it's there's a lot of cool stuff going on with that. So I'd like to sort of start by, first of all, for everybody watching, what is Bittensor?
Right. Okay. So this may take a while, but I'm going to try and explain a bit about machine learning and AI in a nutshell, and kind of work up to what Bittensor is. But in a nutshell, Bittensor is combining both AI and blockchain, right? So if you're a LinkedIn recruiter, this is kind of like your dream, right? You can hit all the buzzwords in one go. So what is it? So if you look at machine learning and AI, you can kind of break it down into two sort of main camps. There's some others, but there's two we're going to concern ourselves with. What's called supervised learning, or what's called unsupervised or self-supervised learning. So with supervised learning, it's kind of a case of, here's a bunch of questions, here's a bunch of answers, learn how to map between the two, right? It's like, okay, here's 100 pictures of dogs, here's 100 pictures of cats. I've told you they're dogs, I've told you they're cats. Learn what a dog is, learn what a cat is. And then when I show you a picture, tell me whether it's a cat or a dog, right? That's supervised learning. Unsupervised learning is kind of like, go forth, read everything on the internet and learn, right? Just learn what's going on, right? It's kind of like taking somebody and sticking them in a library and saying, look, just read every book. And then going up to them, asking them, okay, explain how an aircraft wing works, or explain the plot of Macbeth, right? So somebody, has gone in and basically just read what they can, learned what they can, and from there are able to answer much more kind of free form questions, right? Now, you may have seen two particular models recently, GPT-3 and one called DALL-E by the OpenAI project, that showcase this kind of unsupervised learning, right? So GPT-3 is a model where you can give it some starting text and it'll go away and just keep writing, right? You can give it an opening sentence and it'll write a whole, short story for your paragraph or whatever. It's quite amazing, right? And it's been trained by just kind of going through and reading like literally the entirety of Wikipedia and Reddit and a whole bunch of websites, right? And it's just learned a whole bunch of stuff. It's pretty phenomenal. But and DALL-E is a similar one that can do something similar with images, right? You can say, draw me a picture of, a fish on a bicycle in the style of Monet, right? And it'll come back with an image of exactly that. It's phenomenal stuff. The big problem with that is that takes a vast amount of training data, right? And a vast amount of computing power, large amounts of they normally use GPUs. So similar kind of stuff that's being used for things like Ethereum mining and that kind of thing, to process all this data. And the model that it creates, i.e. the thing that you feed the input into and get the output out, becomes so large that most people, you can't just download it and run it locally, right? It's just too big. You would need, a whole cluster of graphics cards with, gigabytes of data, gigabytes of memory on in order to run it, right? So people like OpenAI, they've created these great models, but they're sort of semi-proprietary, right? They're not allowing anybody to just download them and use them, because it's kind of partly it's their proprietary training that they've invested in, but also you can't, as an end user, really use it because they're just too big, right? You can download it and just run it on your machine. So what's Bittensor trying to do? Bittensor is trying to do something similar with unsupervised learning, but decentralized. So if you think about like the way that something like Bitcoin and proof of work works, right? So with Bitcoin, now Bitcoin, if you think about it, is the largest computational network on the planet by like many, many, many orders of magnitude, right? It's like 400 times bigger than all the data centers in the world combined or something. I don't know the exact figure, but it's the amount of computing power in Bitcoin is huge. But within Bitcoin, it's not really doing much, right? It's it's kind of trying to find the way the analogy I use is it's like solving Sudokus, right? And every computer is all solving a Sudoku, and whoever gets there first, they win. They get to choose which transactions go in the next block. Everybody else's work is effectively discarded and wasted. Even the miner that finds the block, the actual result of the puzzle that they were solving is discarded. It's useless. The only thing it's used for is to find who's first, right? And that's the only thing that they use it for within Bitcoin, right? So imagine if instead of doing all that wasted work, you could actually use that work for something far more useful, like training a machine model, right? Machine learning model. So that's what Bittensor is. It's combining like AI and machine learning and a decentralized network in which you have miners on the network, and those miners are not contributing like just, proof of work that's effectively being wasted. What they're doing is they're contributing machine learning capacity, and effectively they're sort of contributing intelligence. Okay. Actually, is when you get right down to it, it's machine intelligence that they're contributing, which is just this quite like mind-blowing thing.
Let me ask you a question, Matt. So obviously, we were talking earlier. I have some experience with GPT-3, the OpenAI, and it's so mind-blowing that you feed it a couple words and what it would write, and you refresh it, and it writes something, and you obviously can check it for plagiarism, and it's all original. So this is kind of scary stuff, because the AI that I prefer is the one that doesn't lock you out of the spaceship. That's the one, the right. one that I'm more in favor of, that like advances technology but doesn't like, sorry,
exactly. Are we creating Skynet here now?
Right.
Now,
we don't want Skynet.
We don't want Skynet.
We want the time machine.
We definitely don't want the T800.
No, yeah, but I want the time machine, Jeff.
Yeah.
Go back and buy some Bitcoin.
We could get the time machine. That'd be cool. And it's funny because Alchemist, as we're kind of getting right there, he's thinking the same thing. You guys are at least building the beginning stages of the T800. The only thing that's missing, though, is all the great stuff that we're going to benefit from in the meantime. So, right when Skynet was formed, there was no blockchain part of it. Nobody was making money except for Skynet. So now, how great is it that everybody that's into crypto might have an opportunity to benefit, before the invent of the T800 for a short time.
And one of the founders of Bittensor, Jake, he kind of says, well, the fact that a killer robot from the future hasn't come back yet and killed us, does that mean that we've not succeeded? Because surely if we're succeeding, then it would come back. But it's the paradox, of course, because if we succeed, they come back and kill us, which means we wouldn't have developed it. That's what happens in Terminator, right? So I don't know, but I mean, as you say, Chip, I mean, it's some of this stuff is truly staggering. The intelligence that's being built up in these systems, and so you mentioned about how people involved in crypto could get involved. Now that's where the crypto part comes into Bittensor. So Bittensor has its own currency, a currency called Tau, and that is used to incentivize people to contribute these computing resources to this global machine learning network. Right. So your computer can be running a miner for the Bittensor network or a validator. It's got a two-step network. I might talk about that a bit more in detail, but there's a couple of different entities that you can run on the network, and you will be rewarded in Tau for running them. But what's interesting,
TAO?
TAU.
TAU.
Tau, yeah. And so Tau was issued. It wasn't like pre-mined. It's a completely fair issue, right? They started off with like 0. There's going to be 21 million. There's a halving every 4 years. It follows the same pattern as Bitcoin in that regards. But the founders didn't do like some big pre-mine or anything like that. They're mining it along with everybody else, right? And what is cool about this is the amount of Tau you receive is proportional to effectively like the quality of your contribution, the quality of the knowledge that you're supplying to the network, right? So, if you imagine you've got a room full of people and they're all just like random people that have just turned up, they're in this room and you are, you're asking them, to whatever, a question, right? if somebody knows, right, you're asking them a question on whatever, astrophysics, right? If you've got an astrophysicist there, right, that's more valuable to you for that question than, somebody who, knows the ins and outs of Chaucer, right, for that question. So you can reward, or rather the network will reward miners and contributors to the network based upon like the quality of their contribution to the network, how much new intelligence they're bringing, how much new knowledge they're bringing to the Network. So Bittensor plus tau equals a T8000.
That's so wrong.
Now NVIDIA have this like AI like chassis with a load of cards in it and stuff, tensor processing units called the A100, and I'm surprised they didn't call it the T800.
That would have been a mistake, probably. Yeah.
Yeah. I imagine that went to marketing, and marketing went, nah.
No. Yeah, it's not good.
We're not doing that. So, yeah.
Are you down with OTC? Please like, subscribe, and click the bell to be notified when the next video drops.